In the following 3 videos, we shall discuss a good requirement properties. It asks how to determine if a requirement is good enough or if it needs some improvement. As we can see, there are a lot of properties for a good requirement, so we shall start with these 4 in this first video. The first property of a good requirement is atomicity. A requirement is atomic one if it cannot be broken into several subparts, several sub-requirements. And of course, such requirement should describe only one situation. Most properties of a good requirement are easier to describe by mentioning typical problems. So, during these 3 videos, at the bottom of the screen, you should usually see typical problems. Like, for instance, one requirement contains several independent requirements for some reason, or some requirement allows discrepancies due to grammatical features of the language. So 2 different people may understand some phrase or sentence differently, and so on. Or maybe description of some several independent situations for some unknown reason are combined into one requirement. All those situations are bad. How to detect and fix typical problems with the atomicity? The best approach here is only to think, discuss and use common sense. There is no any magical formula there. This is only one approach. If we consider some section of the requirement to be overloaded with information and we think it requires decomposition, most likely it is so. Thus, nothing prevents us from creating another version of the requirement and comparing this newer version to the older one. And then we will proceed with the version we like most. So, how to fix typical problems with the atomicity? Analyze and rewrite, restructure the requirement, split into sections, subsections, paragraphs, and so on. You may imagine a structure of a file system. Here we all know that there are directories, subdirectories, files and so on. Imagine you are organizing some collection of photos or something like that, and you see a directory with a lot of files there. So it may be a good idea to create some substructure. The same approach you may use while working with requirements. The next property is completeness. A requirement is complete if it provides all necessary information, if nothing is missing or left out for any reason. For instance, this is already clear to everyone. As you may guess, this is not usually clear and not to everyone. Never in real life such approach may work for long. Typical problems. The non-functional part is somehow missing from the requirement. For instance, passwords must be stored in an encrypted form. What are the algorithm and other technical details here? This is not enough to develop some module of the application. The next typical problem, that only a part of some enumeration is mentioned. For instance, export is carried out in PDF, PNG, etc. What there in etc. How many other formats are there? 1, 2, or maybe 100,000? So we should replace this etc. with a clear list of formats. Or maybe references are ambiguous. See above. Above where? There should be a clear reference. This is extremely dangerous if we are working with some web-based requirements management tool. Where is the above there? We only have our browser screen with some scrolling bar, menus and so on, and this is the only page loaded. So we already at the top of the page. Where above should I look? There is nothing above. So maybe I should click back and go to any other page. This is not a good approach, and this is good. So how to detect typical problems with the completeness? Okay, most of requirement analysis techniques are good, and we shall speak about those techniques in a couple of videos. But usually asking questions and graphical representations are the best. We shall get more information, and while using some graphical approach, we may see on some schema that something is missing, something doesn't fit, and so on. And how to fix it? Once we see that something is missing, we should obtain the missing information. So we ask questions, and then we add the new data into the requirements. Of course, a little rewriting might be needed, and after this rework, this rewriting, we should show this new version to the customer and get his approval. The next property is consistency. A consistent requirement should not contain internal or external contradictions. With internal contradictions, something is inconsistent within the requirement itself. And with external contradictions, some requirement is inconsistent with some other requirement. So here are typical problems. Contradictions within one requirement. Let us imagine such a bad requirement. It is not written on the screen, so getting it in a verbal form is even worse. When a user without login permissions successfully logs into the system, and etc., etc., etc. How does a user that do not have proper permissions may successfully log into the system? This is a contradiction within one requirement. Contradictions between several requirements. For instance, in requirement number 1, it is stated that a button should be red. In requirement number 123, about the same button, it is stated that the button should be magenta. So which color should be this button? This is contradiction between requirements. And such situation may happen if in a table and in a text something is described different, in a picture and a text, requirement and the prototype, etc., etc., etc. So the idea here, we have two places, A and B, and in one place and other place some ideas are written inconsistently. And the last example here, incorrect terminology or different terms referring to the same thing, the same phenomena, etc. For instance, speaking about interface, one may use such terms as window, screen, display, and so on. Of course, in some situations, window, screen, and display may denote the same. But usually, window, screen, and display are not the same. And we should not refer to one thing with all these three terms. How to detect and fix consistency problems? Good memory. As we remember, inconsistency usually happens between several different objects. So we have to memorize that there, somewhere far above, was some object A, and here we have some object B, and there is something inconsistent between them. Here the graphical representation, some schemas and so on is really useful. And once we detect an inconsistency, we are clarifying the situation necessarily with the customer. We may usually not determine by ourselves if the object A is good or the object B is good, or maybe there is object C and object D and all those objects are inconsistent, or maybe in reality there should be some object E and all those existing are bad. So only the customer might provide us with this information. The next property is unambiguousness. An unambiguous requirement should provide only one objective understanding. So it should not contain misleading phrases, non-obvious abbreviations, jargon, and so on. Here are some examples of some typical problems. For instance, usage of terms or phrases that lead to subjective interpretation. Like, some application should work fast. What's fast? How fast should it be? No, this is not objective. This is subjective. What's fast for one is slow for the other one, so this is not good. The second idea, using of unknown or ambiguous abbreviations without decoding. Imagine you see such abbreviation as MKFRC. What's that? Does anybody know? Me neither. I've just written it from my head. But if you see such in real life, what's that? Where is the clarification? Where is the necessary information? If we are using something non-obvious, we should make clarification. And another situation. Imagine you see the next abbreviation, FS. Most will think, wow, that's a file system, and that's right. Or imagine OS. Oh, that's operation system, and that's right for many situations. But what if someone, for some reason, implies not a file system, but some unknown for us application, like some file searcher? What's a file searcher? Something like that. But most people will think about file system while seeing FS. And the last here, writing the requirement, assuming that some parts are absolutely obvious to everybody and doesn't need any explanation. That never goes well in real life. If you assume that there are telepaths, that there are magicians who somehow magically know everything, that there are no such magic in the real world. So please necessarily explain everything in details. Never hope that someone somehow will magically guess what you omitted. With this property, there are indicators, such words or couple of words, that usually lead to ambiguousness. So, if you see such or maybe some other words in requirements, be vigilant. There may be ambiguousness here. And one real quotation from a real world. In case of necessity to optimize large file transfer, the app should effectively use the minimum of random access memory if possible. From the first look, it looks okay. There's nothing bad here, but stop. In case of necessity, how can we detect that? Is it a necessity now or not? Optimize how? Based on what criteria? Large file. What's a large file? 1 megabyte, 1 gigabyte, 1 petabyte. Transfer. How and where do we transfer the file? Effectively. How? What's the effectiveness here? Minimum. What's the minimum? Based on what? In comparison to what? If possible. And what if not possible? So you see how much the question marks are here. A lot of. And that's only one sentence. So a lot of questions should be asked and such a bad requirement should be rewritten in order to be understandable and applicable. How to detect and fix typical problems with the ambiguousness? First of all, look for specific words, phrases and other indicators. Write checklists to understand how can you test the requirement. Because it is really hard to come up with good checklist for requirements that are ambiguous. And how to fix? Use numbers, formulas instead of verbal description. Imagine once again, you may remember that word fast, how fast. But if instead of fast there is something like maximum time 0.5 seconds. Okay, that's good. That's understandable. That's clear. That's objective. And if possible, use references to standards, use accurate technical terms, and so on. And we shall continue in the next video.